In this video, we'll go over an example of using the squeeze theorem to evaluate a limit. In this case, we're trying to find the limit as x approaches 0 of 3x to the fourth times sine squared of 1 over x. Now, what the squeeze theorem says is that if f and g and h of x are functions defined for all x not equal to a over an open interval containing a, such that f of x is always less than or equal to g of x, which is always less than or equal to h of x for all x not equal to a in the open interval. And we know the limit of the left function, f of x as x approaches a, is L, and also the limit of the right function as x approaches a of h of x is also L. That must mean that the limit as x approaches a of the function in the middle must also equal to L. So what you do for these questions when you're trying to use the squeeze theorem, that the function that you're taking the limit of, that's the g of x. That's the one that you're going to have in the middle, and you want to find two functions, f of x and g of x, such that the function that we're taking the limit of is always greater than or equal to f of x and less than or equal to the h of x function. And we want those two functions to be such that the limit as x approaches a, in this case as x approaches 0, of those functions is equal to the same value. So therefore the limit of the middle function must also equal to that same limit value. So here's what I would do for this one. Now, for both sine and cosine, that we know that no matter what value of x is, that sine of x is always between -1 and 1. So we know that's always true. So that would be for any x, so therefore we could also say that sine of 1 over x is also between -1 and 1. Now one thing to know, we're taking the limit as x approaches 0, so it's not actually equal to 0. That's why we could take sine of 1 over x, because we're getting really close to 0, but not actually equal to 0. So we're not going to have 0 in the denominator. So we have the sine of 1 over x is always between -1 and 1. Now we could further say that if you were to square that function in the middle, that value for the sine squared of 1 over x, that's always going to be non-negative, so we know that'll be greater than or equal to 0. And it'll still be less than or equal to 1, because if you square any value between -1 and 1, it's still less than or equal to 1. So we have, so far, the sine squared of 1 over x is between 0 and 1. And now if that's true, then if we multiply each term by the 3x to the fourth, so multiply all three functions by that 3x to the fourth, that inequality will still be true. So 0 times 3x to the fourth, that'll be 0. And in the middle will be the 3x to the fourth sine squared of 1 over x. Has to be less than or equal to 1 times 3x to the fourth, so that would just be 3x to the fourth. So the function that's within our limit is always between 0 and the 3x to the fourth. So that's our f of x and our h of x. So we know that's true. So we know since the 3x to the fourth is always 3x to the fourth sine squared of 1 over x is always greater than or equal to 0 and less than or equal to 3x to the fourth. And we also know the limit as x approaches 0 of the function on the left, which is 0, is equal to 0, which is also equal to the limit as x approaches 0 of 3x to the fourth. So we know the limit of the left and the right hand side functions are equal to 0. That must mean that the limit as x approaches 0 of the one in the middle, the 3x to the fourth sine squared of 1 over x, must also equal to 0. So it must be squeezed in between, because so you could visualize this a little more. So we had this inequality is true. So if we took the limit as x approaches 0 of each term, then that limit also must be true. So that inequality is true. And we know this on the left is 0, this on the right is also 0. So therefore what's in between must equal to 0. So that's why we know what that limit is equal to using the squeeze theorem.